Okay, thanks everyone for joining us. This is the SingularityCE community call for August. We didn't have one last month because it fell on the July 4th holiday in the US. So we have a little bit of catching up to do with what's been going on in development on the SingularityCE project. I'm going to jump across first, though, to just talk about the latest patch release of the 4.1 series. So 4.1.4 came out at the end of June. If you haven't seen the change logs or had a look at this is a relatively kind of small update in the 4.1 series. There was a fix for the app armor profile so that we use the correct app armor ABI on older versions of Ubuntu. This actually doesn't have any functional effect. It's just that if you installed Singularity from packages on Ubuntu older than 2310, it was spitting out a warning at package install time because it was trying to use an ABI4 app armor profile, which isn't supported on those distros. So this just fixes it so the error doesn't appear on package install. No functional change there. We have a few kind of behind the scenes things. So when OCI images and Docker tarballs are taken and converted into Singularity images, the code that was doing that unnecessarily created some intermediate structures on disk, which uses more space and can take additional time and consume I/O on large systems. So we've modified the code there to avoid some unnecessary copies and extractions when you're working from OCI images and Docker tarballs, and also to avoid a temporary copy of the image when you're building from a Docker file into an OCI CIF image using the Singularity build OCI functionality using BuildKit. The other fix we have, which is a kind of behavior fix rather than just a kind of optimization, is this one at the bottom. So the files from directive could be used in a definition file to copy files between stages in a build. So if you have a multi-stage build, you can use files from to copy things between stages. Because of some code we have to kind of secure the use of paths in that, so you don't sort of escape from the directory which is holding a build stage. We had a problem where symlinks that pointed to a directory above the location of the symlink I didn't copy properly. And that was because the kind of security check on where the symlink was pointing was too strict, and it wasn't allowing you to go up a level when going up a level was still inside the destination where your kind of build stage is being assembled. So that bug has been fixed now. So if you're using relative symlinks and copying relative symlinks between build stages, then you won't hit an issue that it sort of complains that you're not allowed to do that. Any questions on this one before we carry on? Okay. If I hop over to the change log, we can see that the changes since last release section is kind of filling up now with more new features and functionality. So the idea is that the SingularityCE 4.2 release will happen by the end of the month, with the release candidate probably in 1 or 2 weeks from today. So we're building up various things. There's the ability to use multiple environment variable files, and Carlos, who's a relative newcomer to the Sylabs team will demonstrate that shortly. There's also some new configuration file directives for anyone who wants to restrict use of namespaces more granularly. And then we've shown in previous community calls the data package command for creating data containers in the OCI mode, and how you can use a layer format flag for Singularity push to take OCI CIF images that you've created for OCI mode and push them into a registry with the tar layer format that can be pulled and executed by other OCI runtimes such as Docker and Podman. So we've kind of touched on these things before, but the kind of notable changes since last time we spoke about this is the bullet points down the bottom here. The biggest chunk here is that we now support writable overlays in OCI mode that are embedded in the CIF file. And I will go through this and elaborate on this more a bit later on in a demo. So that's these 3 bullet points here. We've also imported recently, or Carlos has actually imported the instance run command, which Aptainer added, so that you can, when you start an instance, you can choose to start an instance not with the start script in the definition file, but the run script in the definition file. So Singularity instance start will start an instance using the start script in the definition file, and the new Singularity instance run will start an instance with the run script in the definition file. There's a few outstanding bug fixes that we will be kind of making available for the 4.1 series 2. So there's some fallback for OCI mode that wasn't working correctly. So basically when fuse mounts or kernel mounts weren't available, we should fall back in certain situations to extracting containers to a temporary folder, a sandbox, and running from there. And we fixed some stuff there with that fallback. There's also a fix contributed from a non-Sylabs third party who has found that if you are building from local images, where the local images have symbolic links that are paths that are part of the base container environment that Singularity ensures are present in all containers. So that's things like if you have a symlink from var temp onto temp, then if you try to build from images like that, local images rather than things you're pulling from a Docker registry or the library or similar, then the build would fail. So that person contributed a fix which has been tidied up and merged and will come out in the next 4.1 patch release. I should point out that as well as these kind of fixes, there's a requirements section here. So we use quite a lot of dependencies that update often. And in the Go ecosystem, there's now kind of a move towards dependencies chasing Go versions faster than the kind of official support lifecycle of the Go developers themselves. So for Go, they provide patches for the for 2 minor versions. So you kind of get around about a year's worth of updates for security fixes and critical bugs and things before you have to jump up a minor version. However, we're starting to see now more dependencies which are jumping to newer Go versions more quickly. So at the moment, we've kept it as kind of simple as we can. The current state of the main branch requires Go 121.5 to build due to dependency updates, but we have things outstanding which will require us to jump to a minimum of Go 122 in the near future. And we're trying to hold off until Go 121 drops out of the upstream support. But if there is a security issue in the dependencies which have jumped forward, then we'll have to follow them. This is something which seems to be, problematic for a few projects at the moment, um, and particularly where Linux distributions, which might be a bit behind chasing Go versions, um, build packages from projects. So we'll have to see how that pans out with regard to the packages that we build for the Apple repositories for Red Hat, Alma Linux, Rocky, and so on. We'll see if there's any issue there in the future. So that's kind of an overview of what's been going on recently. Um, what I'd like to do now, if there aren't any questions, is hand over to Carlos, and he's going to do his first demo in a community call since joining us, and show how this feature for handling multiple environment files works. Do you want to start sharing then?
Sure. Thank you, David. Okay, you can see my screen, right? Okay. Um, I'm gonna present to you now, as David said, this new feature that allows us to use multiple environment files when executing Singularity. So for this, I have a small demo. As you can see here, I have a small definition file for an image. It's very simple. It's just an Alpine image where we define three variables. The value of the variables I will be showing you is the source of the variable. No, um, all three of them says def file because it were defined in the definition file. So I'm gonna build this. Okay, okay. 1 second. Just 1 second. Okay, here we go. Now I have my stiff image for this, and now I can execute. Um, uh, and I want to show uh, every variable that start with Sylabs. Okay. So as you can see, we have these the three variables I just showed you before, and now what I'm gonna do is gonna uh, redefine new variables, especially uh, this one defined in these files. As you can see in file 1, I have the Sylabs 1 and Sylabs 2 variables defined, and the value is m file 1 because they are defined in this file. So what I can do now is to add the m file flag and add as an option the file one uh, file. So as you can see, now my original three variables, two of them were overridden by the ones defined in this file, in file 1. And this is the usual behavior of Singularity, and this is the the old behavior. And the new feature is that now we can add more than one M file. This can be done just putting the file here as a comma separate list, or also I can add the M file as a new flag. Okay, and what happens here is that I'm gonna um, just 1 second. First of this, I'm gonna show you what file2 has. Okay, you can see in file2, I just defined Sylabs1 variable. So if I run this command using the two files, as you can see, I'm overriding again the the variable defined in file1 with the one defined in file2. So that's the behavior. Two things I want to point out here is that the first one is that um, the order of the files we define in the command line matters. So, for example, if I do the same exact command, but I change the order of the files, what happens is that I don't see the file2 anymore because the file1, as you can see here, has priority in this case. So the later file has priority over the previous file, and the file has priority over the original variable in the image. Um, and that's it. That's how this works. Um, what else? Oh, and also we have the usual behavior. What happens if I want to override a variable? Just put a new env flag, not env file one, but the env files, for example, Sylabs one um, command line, for example, that's the value. As you can see, the Sylabs one variable is overriding again, but this time I got a warning because I'm using a hand-picked variable over the one defined in the files. Now the question is why this is important, why this is useful. Okay, this feature was developed uh, motivated by a user-reported issue we had in GitHub. And this is the example that person gave us. He wanted to run his application using different M files because, as you can see, he was using a rather complex application. He has a, a backend framework, Django. He have a database running. So it's the usual too for all these applications to have his own environment files. This person said to us that he was concatenating every environment file before executing, so was a bit cumbersome workflow. So I think this is uh, the most common use case for this. I don't know. I think it's very useful. So I hope this is going to be useful for any one of you and for the community in general. And thank you.
Great, thank you. Any questions on this piece? Okay, we will move along then. So the next thing that I'd like to show again briefly is in this point here. So OCI mode overlays. I'm going to switch into my terminal here, and hopefully everyone can see this. I'm going to begin by pulling down just a standard Ubuntu image into an OCI CIF file. So in OCI mode, I've got this OCI CIF file. Now, whenever I run a container in OCI mode, because we're trying to be more compatible with the behavior of other OCI runtimes, we have a writable temporary file system in place. So I can do things like create files in the container. with touch, and it doesn't give me an error. It actually goes ahead and creates that file. But the place where it's creating it is, like I said, a writable temporary file system, which is in memory and only exists for the lifespan of the container. So if I then go and run an ls looking for this file foo, it's not there. So foo was created in this invocation, but it only existed until this exited. And it's not there in the CIF file. There's no persistence. Until this point, if you want persistence, what you've been able to do in OCI mode is to use the dash dash overlay flag. And with that one, you can basically mount a directory or a separate overlay image file as an overlay on your container. And you can use that, but it's kind of awkward to distribute things then because you have your container, but any changes are in a separate overlay, be it a directory or a file. If you kind of made changes, then you have to distribute those together somehow if you want someone else to use the container with those changes. In the native mode, the non-OCI mode of Singularity, for a long time, it's been possible to add a persistent overlay into a CIF file so that it carries along with the container. We couldn't do this in OCI mode until quite recently with functionality which is going to be in the 4.2 release. So what's been added now is the ability to use Singularity Overlay Create to, first of all, add a writable overlay into my OCI CIF file. And if I go ahead and do a CIF list of my CIF file, what's actually happened behind the scenes is that this ID number 2 has been added, and this is actually the overlay. My image in this case has a single layer originally, and then below we have the OCI manifest and configuration, and then a root index of the CIF file. But this one here, if we inspected it more, it would be apparent that this is now an extra layer in the image. And this layer is in ext3 format. So it's an ext3 file system, which is something that we can write to. It's the same format we use, ext3 image, in native mode, but it's inserted into the CIF file differently because in an OCI CIF file, we are using the OCI constructs like the OCI image manifest and config in order to kind of keep the structure of the image. Right, so now I've got that file. What I can do is go ahead and this time add the writable flag so that I'm writing not into a writable tempfs where my changes will disappear, but I'm writing into the overlay. I'm writing actually into the image. The image is writable. And then if I go ahead and list the contents of the root directory, then I find that this time my changes persisted. Okay, so this has actually gone into the overlay, just like it would if you had an overlay embedded into a CIF file in the non-OCI native mode. This line here, this unknown argument ignored lazy time, we'll try and tidy this up before release. This is just because on my system, Fedora, there's some default mount options specified, and the Fuse program that we're using to mount the overlay doesn't understand this option, so it's ignoring it. So this isn't an error. This is just something which pops up because of the Linux distribution I'm running on and how it's configured. So by default, then the overlay is always mounted read-only when we run with outwritable. So that's why we see the persistence. And if we try and batch a file, it will still succeed because the writable tempfs is in place, but we won't see the bar persisted unless we run with writable, in which case it's now persisted. This is a little bit perhaps unintuitive, that you can still write to things, write it into the image temporary FS without writable, but it's the closest thing we can get to supporting OCI-like behaviors, but also matching well with what the native mode Singularity does. The only difference with native mode Singularity is that writable tempfs isn't on by default there. If you turn it on manually, you'll have the same behavior between the OCI mode and the native mode with that writable tempfs turned on manually. So what can we do once we've got an image with an overlay? Well, we can always go ahead and push our image, our OCI CIF as is, up to the SCS library or another OCI registry like Docker Hub in this case. So what we have here, we actually see that it sends info synchronizing overlay digest to OCI image, and then it's uploading the image. Behind the scenes, what's happening here is that when we added the overlay to our OCI CIF, we updated the configuration and the manifest of the OCI image, which is inside the OCI CIF, to reflect the initial empty overlay that was added. When we modified our image by writing a new file, we actually changed the content of the overlay. And before we share it via an OCI registry or whatever, we actually have to go ahead and recompute the digest of the overlay and update the manifest and config, because when you interact with a registry, you use hashes to refer to layers and things. So we have to kind of make sure those match. So that's why you get this message. If you have an extremely large overlay, you might add an overlay with gigabytes of things in it, then this may take a little while because it has to compute the digest and update the manifest and config before you can push this up into a registry. So as well as working with the overlay here, what we might also want to do at some point is go from an image which is writable to one which is no longer writable. So kind of make our changes permanent. So we have a new command which is not implemented for the native mode overlays, but has been added for these OCI CIF overlays, where we can say overlay seal. And what happens here is that if I seal an overlay, my EXTFS layer is converted into a read-only layer. And now all my changes have been kind of made permanent in the image. If I try and write a file again, it will tell me it doesn't contain a writable overlay. It's been sealed up. Just whatever changes I had in up to that point in the overlay have been converted into a permanent read-only layer. So my image is kind of sealed against future change. One of the reasons that you might want to do this is because in the past, we demonstrated that you can push an image up to a registry using a new flag called layer format. And you use this layer format to specify a tar layer format where we're going to push the content of the image to the registry in a way that it can be consumed by other OCI runtimes like Docker and Podman and so on, right? They only support tar layers. They don't support the SquashFS format that Singularity uses by default, and they don't support the EXTFS format, the XT3 images, which we use for the writable overlays. So in order to kind of take an image that you've been working on with an overlay and then push it up for consumption with Docker and Podman, you have to seal it first before you can then push it up with layer format tar. And that will allow you to do that. There is a caveat here at the moment. This is not entirely finished. We have an issue with some types of changes which have been made and some versions of the Fuse Overlay FS program which we use to handle these overlays, which means at the moment, if you then try and run the Docker image, you will hit an error at present, right? So things aren't entirely finished yet. You'll hit this error, but as soon as we've kind of tackled this last bit of the overlay support, then you'll be able to create an overlay, modify an image as you wish, seal the image back down so it's read-only, and push it up in a manner with which it can then be used by Docker or Podman or other OCI runtimes. So hopefully what we've got here then is for 4.2, the flexibility that you have with the persistent overlays in the native mode added in for the OCI mode now, but with the additional ability to use them in a sensible way, given the extra interoperability with registries and other runtimes, which we're concentrating on in OCI mode. Does anyone have any questions on this piece? Okay, then. So as I said, that overlay bit is nearly there, but not quite. And the CE 4.2 release candidate, by which time that should be finished, is looking like 1 or 2 weeks from now. If anyone has any kind of general questions or has tried out any of the stuff in 4.2 and wants to raise any issues or so on, then now's a great time. Alternatively, if you're watching this on YouTube afterwards, then it'd be great to hear any feedback via either the Google Groups thread for this call or the GitHub discussions thread for this call, or if you found a genuine bug which you're sure about, you can report that as an issue as well. So yeah, I guess that's what we've got to show for this time. Hopefully it's a demonstration of useful things which will interest you for 4.2 shortly. I guess we'll open the floor and for any general questions or discussion on these things or any other topic before we finish. Any questions at all? If you want to just shout out, we can try and answer them. All right, it's a quiet call then, but I think we'll finish now a bit early for today. As I said, any comments, any things you think of afterwards, please don't hesitate to jump on the Slack or the GitHub discussions thread or the Google Groups thread and chat to us there. Thanks for joining. We will have another one of these in September, the first Thursday as usual. So hope to see you there.